So looking at finding the least common multiple of monomials is going to be similar to finding the greatest common factor of monomials. We're going to look at this in two different parts. We're going to look at this in the coefficient part, and then a variable part. Okay. So when you're finding the least common multiple of the coefficient part, that's going to be the same as we have previously done in the first objective of this unit. But we're going to look at how to incorporate this variable part. So I'm actually going to do method 2 first because it's sort of the extended version of method 1. So the general idea is that you want to pull everything apart into its component pieces, so it's prime factorization. So I'm going to erase this and kind of walk you through it a little bit. So if we're looking at this, we prime factorize our numbers the same way that we did before. So you can make your factor tree off to the side if you want. So for 15, we could have 3 times 5. So if we're looking at 15x cubed y cubed, the 15 will just be 3 times 5. But then we need to look at the variables. So you want to remember that exponents are simply talking about the number of times something is multiplied by itself. So x to the third is just saying we're going to take x times itself 3 times. So x times x times x. And again, y to the third is y times itself 3 times. So we would have times y times y times y. And we want to do the same for 40x squared y to the fourth. All right, so go ahead and do your factor tree for 40. So you might do 4 times 10, and 4 would be 2 times 2, 10 would be 2 times 5, so that would give us 2 times 2 times 2 times 5 for the prime factorization of 40. And then we want to go ahead and take and expand our variables there. So we would have x times x, and then y times y times y times y. Now we want to go about this in the exact same way that we did a constant LCM, which is we want to look at both groups, both prime factorizations. We want to take the most of any given prime. So whether that prime is a number or the variable, we can kind of think of those as primes. So we're going to start at the bottom and work our way up. So let's look at 2 first. The largest group of 2's is this 3 2's down here. So that's what I'm going to take for my LCM. So remember, our least common multiples need to be greater than or equal to the original numbers, which is why we're taking the larger amount. Or if they have equal amounts, we'll pull the equal amounts. Okay, so 3 2's is the most 2's. Now we'll look at the 3's. Well, our first prime factorization has the most 3's, so let's take that. Now we'll look at the 5's. Each of them only has 1 5, so it doesn't matter which we take, but remember, we can only pull from one prime factorization. We can't pull from both at the same time for the same prime. Okay, so let's look at x's. So our first prime factorization has 3, our second has 2, 3 is more than 2, so we'll take 3 x's. And again, looking at the y's, our first prime factorization has 3 y's, our second one has 4, 4 is more than 3. And now we want to condense this, right? So 2 times 2 times 2 times 3 times 5 is what we want to ask ourselves there, which is 120. We want to go ahead and express the variables in their exponent parts as well. So we want to express these back as exponents. So x times x times x, that's x times itself 3 times. So that'll be an x cubed. Y times y times y times y, that's y times itself, or y to the fourth. Now, we want to notice something about these variables that we're going to use in the second method, which is the kind of quicker method. So if we look at the exponents, so we have x to the third. If we look at the original x's, we just picked the one with the larger exponent on it, right? Multiples greater than or equal to. So if it has to be greater than or equal to the original 2, I couldn't pick x squared because then it would be smaller than that first monomial there. Now when we go to y, we picked y fourth. So on our original ones, a y to the third or a y to the fourth, I picked the larger of the 2. So that's how we're going to be working with this. You want to think of LCM as where we're going to take the most possible prime factors available, which means we're going to take the larger of our exponents. So let's see how that works in this example up here. So what was actually method 1 is when taking the prime factorization here, we're simply going to find the LCM of x cubed times y to the 4th times z to the 5th. So we're right here, this example, and x squared times y times x to the 8th. So all we're going to do is pick the greater exponent of the variables. And I actually don't want to say common because they actually don't have to have the variable in common. So we're going to pick the greater exponent of the variables. So if we're looking at x's, x to the 3rd or x squared, we picked an x to the 3rd. Y's, y to the 4th or y to the 1st, we picked a y to the 4th. Z's, z to the 5th, z to the 8th, we picked a z to the 8th to then come to our least common multiple. So let's do just a few more examples and take a look at this in practice. Okay, so I'm going to prime factorize my numbers just as I always have. Or if you're really good at thinking of multiples in your head, then you can do that. So I'm going to rewrite these. So we're going to have 12x squared y z to the 4th, 24x cubed y to the 4th. But this time I'm not going to expand my variables. If you want to, go for it like we did in method 2. But I'm going to do the quicker method 1. So 12 is really 2 times 2 times 3. And we're just going to leave the variables as they are. So x squared y z to the 4th. You might want to put a little 1, an exponent of 1 on that y to remind yourself that that's an exponent of 1. All right, and then 24 will be 2 times 2 times 2 times 3. And we had an x cubed y to the 4th. Okay, now we want to pull out our largest bits, right? So our LCM is going to equal the most 2's, so that's 3 of them, the most 3's, right? They have the same numbers, so it doesn't matter which one I pick. And then the largest exponent. So let's look at the x's. Between a 2 and a 3, the 3 is larger. Look at the y's. Between a 1 and a 4, the 4 is larger. And then we have a z to the 4th, and the other one doesn't have any z's at all. But what's bigger, a z to the 4th or no z's? Well, a z to the 4th is larger than nothing, so that's the one we're going to pick. So we end up with a least common multiple of 24 x cubed y to the 4th z to the 4th. And that would be our final answer. All right, so let's keep going. So in this one, I'm just going to kind of do these in 2 separate pieces. I'm only going to write out the bits for the numbers, and I'm not going to rewrite the variables. So 6, we know, is 2 times 3. 10 is 2 times 5. So when I go to find my LCM, my number part is going to be 2 times 3 times 5, taking the most from one prime factorization or the other. And then I can just look at my variables. I can say which is bigger. R to the 3rd is the larger of the r's. S to the 6th is the larger exponent of the 6's. And then I just simply need to multiply together those numbers, 2 times 3 times 5, to get 30, R to the 3rd, S to the 6th. So this is going to work very similarly for when we have a trio of numbers. So we're going to go ahead and just prime factorize our numbers to start, right? So we can get rid of that coefficient part or the number part. So we'll have 2 times 7 for 14, 2 times 2 for 4, and 2 is just 2 or 1 times 2, right? It's already prime. So when we go ahead for our LCM, we'll get our number part. We'll pick the most 2's, which is 2 2's, the most 7's, which is 1 7. That's our number part. Now we want to look and compare our variables. For A, we have an a to the 1st, right? Remember the 1's not written, an a squared, and an a cubed. Well, a cubed is the biggest, right? This is least common multiple. We're taking the most. So we have a b to the 1st, b to the 2nd, and a b to the 2nd. They're the same for the last 2 monomials, so it doesn't matter which one I pick. We're just going to take down one of the b to the 2nds. And then for the c's, we have a c to the 5th, a c cubed, and a c squared. Well, 5 is larger than 2 or 3, so we're going to take the c to the 5th. Finishing off by multiplying the 2 times 7 to get 28. A to the 3rd, b squared, c to the 5th. And then we're all done.